welcome to section 7.5. All right, and this is where this chapter gets fun. We're going to start solving equations with rational expressions. Yay, so that means, well, just glance through the page. You'll see lots of rational expressions. Now, we're not necessarily just subtracting, just adding, just multiplying, just dividing. We're going to do all these things in order to solve equations involving them. Okay, so before we do that, let's start with solving a regular linear equation first, just to review. Remember, the goal is to solve for x here. So I'm going to start by subtracting 16 from both sides. Now this is at the point where you should be able to do this without writing 1 minus 16. You can just do that. 1 minus 16 is negative 15. Okay, then we're going to divide both sides by 3. Negative 15 divided by 3 is negative 5. Okay, so they're solving a basic linear equation. Okay, now let's do one that's solving that involves fractions. Now this doesn't actually involve a rational expression because there's no variables in the denominator. So this is a little bit easier than the ones we're going to get to down here where there's x's in the denominators. Okay, so if you're solving an equation that has fractions, the easiest way to do it is to first get rid of the fractions and then turn it into a regular equation and solve it from there. So to eliminate the fractions, we would have to multiply both sides by the denominators, by the lowest common denominator, big enough so that it eliminates all the denominators. Okay, so what I'm saying is between 4, 5, and 20, those three denominators, the lowest common multiple of those is 20, right? Because 4 and 5 are both factors of 20. So if we multiply both whole sides of this equation, because you remember you can do anything to an equation as long as you do it to both sides, we're going to multiply both sides by 20. So first we have to rewrite the equation and then put some big parentheses around everything on each side. I'm going to multiply the left side by 20 and the right side by 20. Okay, now we're going to distribute. When we distribute that 20 into those fractions, we get 20 times x over 4, 20x over 4, plus we get 20 times 4 over 5, so that would be 80 over 5, equals 20 times 1 over 20. Now that one we can just simplify. 20 over 20 is 1. Okay? And let's simplify these. This should make the fractions go away. And 20 over 4 is, in fact, 5. And 80 divided by 5, well, actually, if I hadn't have multiplied that together, it would be a little easier to do. So I'm going to unmultiply that. It was really 20 times 4. Okay, and 20 divided by 5 is 4. So that goes away. So we have plus 16. So we have 5x plus 16 equals 1. Well, now it's an easy equation that you can solve. And actually, it's very similar to the one we just did up here. So 5x plus 16 equals 1. Now I'm out of space, so if that happens to you, draw a little arrow so we can follow. So we're going to have 5x equals, subtract 16 from both sides, so negative 15. So divide both sides by 5, x equals negative 3. Okay, if your equation involves fractions only, with only numbers in the denominators, and no variables, no x's, you can stop here. If you have x's in the denominators, which is what we'll have in the ones coming up, then you have to check all your answers. So we'll do plenty like that, but I just want to make you aware now. The only reason I'm not checking the answers is because there are no x's in any denominators here. Let's do this with another one to make sure we've got this process down here. Okay, now this one again only has numbers here in the denominators. So how to get rid of the denominator, or how to solve this equation? First, get rid of the fractions. Get rid of the denominators. So the lowest common multiple here between 3, 5, and 15 is 15 because 3 and 5 are both factors of 15. So we can multiply both whole sides of the equation, now you need a big parenthesis or bracket here, by 15. Okay, and on the left side, if we distribute that 15, we'll have 15 over 3. Now 15 over 3 is 5. So we're going to have 5 times x plus 2 minus, okay, when we distribute this 15 over here, we'll have 15 over 5, which is 3. So 3 times x minus 1. and then 15 over 15 is 1. We've converted it into a simple linear equation with no fractions, so from here it should be fairly easy to solve. We just distribute and solve for x. So we have 5x plus 10, distribute that negative 3, so minus 3x plus 3 equals 1. So 5x minus 3x is 2x. 10x plus 3 is 13. So we have 2x equals 1 minus 13 is negative 12. So x is negative 6. All right, and again, make sure you're working these without me first, okay? And then just watch it with me to make sure you're getting it. Okay, how do you solve it if it has x's in the denominators? Okay, that's really when you have rational expressions. The real only difference is that you then have this step 3, which is you have to check your answers. Because when you multiply, well, I'll just show you when we do it, but when you multiply both sides by an x, you can sometimes introduce what's called extraneous solutions. They're answers that you get, but that aren't really answers to the original equation. So sometimes that'll happen, all right? So let's work on this one here. Now we only have one denominator, so to get rid of it is fairly simple. We just multiply both sides by that denominator. So we're going to multiply both sides by x. So we have x times 2 plus 6 over x equals x times x plus 7. Okay, and then we distribute out that x here, so we'll get 2x plus, now 6 over x times x, the x's cancel, so we just get plus 6 equals, on the right side we have an x squared plus 7x. Ooh, now that's interesting. You always want to ask, what kind of equation is this? And this is a quadratic equation because we have an x squared. So you hopefully remember the first step to solving a quadratic equation is to get it equal to 0 on one side. So we're going to need to move all the terms to one side. Now this x squared is currently positive, so I'm going to leave it on the right side so that it stays positive, and move the 2x and the 6 over to the right. So if I subtract 2x from both sides, we'll have 7x minus 2x, which is positive 5x, and then we have 0 minus 6. Okay, let's see. Hopefully this is a solvable equation here. Let's see if this factors. Okay, x squared breaks down into x and x. Now both of them, no, one has to be positive and one has to be negative to multiply to a negative. And so I'm going to go with 6 and 1. How about a positive 6 and a minus 1 so that they'll add to 5x. The outside term here is negative x. The inside is 6x, so that does work. Then we set each factor equal to 0. So we'll set the x plus 6 equal to 0, and we get x equals negative 6. And we set x minus 1 equal to 0, and we get x equals 1. Okay, now because we have x's in the denominator, these are not necessarily our answers. One of them might be, they both might be, or it might be that neither of them is. But we have to check first before we can box them in as our answers. Okay, and label which one you're checking, be real organized here. So we're going to check, and I recommend even writing the word check. Let's first check x equals negative 6. So what you want to check it in is the original equation. So we're going to plug it in up here. We'll have 2 plus 6 over negative 6. The question is, does that equal, so question mark, does that equal negative 6 plus 7? So plugged in the negative 6 for x here and here. And let's see. 6 over negative 6 is negative 1. So that's 2 minus 1. Does that equal, now on the right side we have negative 6 plus 7 is 1. 2 minus 1 does equal 1. So that actually is a solution. So we can go box that. Very good. And now let's check the other one. So the other one is checking x equals 1. Let's plug that in and see. We have 2 plus 6 over 1. Does that equal, big question mark because we don't know, we're checking. Does that equal 1 plus 7? Let's see, 6 over 1 is 6, so 2 plus 6 is 8, and yes, that does equal 8 equals 8. So that one is a solution as well. So this rational equation right here has two solutions. Negative 6 and 1 are both solutions. Alright, so there's your first rational equation solved and both solutions checked. Alright, let's do another one. Make sure you're trying these on your own first. Pausing this video. Okay, so on this one, this one's going to be a little harder to figure out what we need to multiply both sides by. In other words, what's the lowest common multiple of all those denominators? Just like we did, or just like we found when we were adding and subtracting fractions here. So let's see, let's factor here. This x squared plus 2x minus 15. I'm just going to go off to the side and scratch work over here. Scratch work. X squared plus 2x minus 15. Let's see how that factors. X squared factors into x next. 15, how about, now it's a minus 15, so how about 5 and 3? Let's go with the plus 5 and the minus 3. That way they'll add to a positive 2 in the middle. And, okay, so here's what I'm noticing. This fraction right here, I can rewrite in terms of both that denominator and this denominator. So let's go ahead and just rewrite the whole thing first before we actually get to solving. But I'm going to come over here kind of to the left and do it. Okay, so all I'm going to do is factor that denominator there. So we have x plus 5 and x minus 3 is what that denominator factors into. Then I'll recopy the rest of it. So minus 4 over x minus 3 equals negative 2 over x plus 5. I prefer to write this negative with the 2 because otherwise it kind of blends in with that fraction bar there. So this way it's hopefully we don't miss it. Okay, so now we can look at, well, what is the lowest common multiple of all these denominators? Well, the x minus 5, we definitely have to multiply both sides by x plus 5 to get rid of that. And if we multiply both sides by an x minus 3, it'll get rid of that. And that will get rid of all our denominators. So we're going to multiply all three parts here by x plus 5 and x minus 3. Okay, that's like one big group there. All times the left side here, so that's all times 7x over x plus 5 times x minus 3, just recopying, minus 4 over x minus 3, equals, now on the right side we have to multiply it too by x plus 5 and x plus minus 3, and that is times negative 2 over x plus 5. Okay, now we distribute and simplify. So if we distribute this whole thing out, this whole thing, x plus 5 times x minus 3, all times this big first fraction right here, well, I'll write it out in this first example to make sure you see, but everything's going to cancel. So we'll have x plus 5 times x minus 3, that's this here in the blue, times 7x over x plus 5 times x minus 3. Okay, and one thing I should have said here is, if it helps when you're multiplying these fractions, think of this as over 1. Okay, so you're multiplying these two numerators and multiplying those two denominators. So that's why this x plus 5 minus x minus 3 went right here into the numerator and not into the denominator. Okay, and like I said, see, then they cancel. We have x plus 5 over x plus 5, x minus 3 over x minus 3. Now we distribute it to the second fraction, 4 over x minus 3. So we have x plus 5 times x minus 3 times 4 all over x minus 3. So here the x minus 3's cancel. And on the right side, there's nothing to distribute, but we can go ahead and cancel those x plus 5's. And so we have it equals negative 2 times x plus 3, or x minus 3. Whew, so we got rid of the fractions. Now let's rewrite it to make it prettier. Here we have 7x minus 4 times x plus 5 equals negative 2 times x minus 3. Now the nice thing here is this one is not a quadratic. This one's a linear equation. Okay, so we don't have to get it equal to 0 and factor like we did on the previous example. Instead, we can just simply solve for x. So let's distribute that out and the negative 2 out as well to get 7x minus 4x minus 20 equals negative 2x plus 6. And then combine like terms, 7x minus 4x is 3x. So we have 3x minus 20 equals negative 2x plus 6. If we add 2x to both sides, we get 5x over here. And if I add 20 to both sides, I'll have 6 plus 20 is 26. So we get x equals 26 over 5. Actually, let's write that over here. X equals 26 over 5, which does not simplify. We do have to go check though, check our answer because we did multiply both sides by x's. So let's check x equals 26 over 5. Let's go plug that in up here in the original equation. Okay, so plugging that in, we have 7 times 26 over 5. Denominator over here will have 26 over 5 all squared plus 2 times 26 over 5 minus 15. I know this looks messy, but I'm going to show you a shortcut for solving this in a minute, or for simplifying this in just a moment. 26 over 5 minus 3 equals 2 over 26 fifths plus 5. Okay, so it looks like if we multiplied, well, there's two ways to do it. One is to do it algebraically. I'm actually just going to show you the real simple, this is sort of the cheap method, but it does work. And that is to calculate this on your calculator. Calculate your left side. Okay, when I plug that into my calculator, this whole left side, and you have to be real careful about parentheses when you do this, but when I do, I get 0.196078. When I type this in onto this other side into my calculator, I get the same thing. Okay, so you can do a quick check by just approximating if the numbers are just terribly ugly like in this case, and it does work. Okay, so this is in fact an answer to that rational equation up here. Alright, let's do another example. Let's solve this one. 5x over x minus 1 equals 5 over x minus 1 all plus 3. So clearly the denominator here is x minus 1. It's the only denominator we have. So we'll multiply both sides by x minus 1. So we have x minus 1 times the whole left side equals x minus 1 in parentheses, those parentheses must be there, times the whole right side. Now if you left off the parentheses around this x minus 1, it wouldn't be correct because it would say this. It would say x minus 1 times 5 over x minus 1 plus 3. What this says is that you only distribute the negative 1. Okay, you have to have parentheses around it to indicate that you distribute the whole x minus 1. So that's wrong. Don't do that. Okay, so then over here on the left side, x minus 1 over x minus 1 cancels. And over here we've got to distribute. So we have 5x equals x minus 1 times 5 over x minus 1. The x minus 1's cancel. We just get 5. And then multiplying it over here, it'll be 3 times x minus 1. This is a fairly simple linear equation as well. So we get 5x equals 5 plus 3x minus 3. We'll just solve this linear equation. So moving this 3x over, we get 2x equals 5 minus 3 is 2. So we get x equals 1. Well, that's simple enough. Now let's go check. Remember, you have to check. X equals 1. Okay, if we plug that in, we get 5 times 1 over 1 minus 1 and equals, we can stop right there because 5 divided by 0 is undefined. So that does not work because that gives us a 0 in the denominator. So this has no solution because the only solution we got actually doesn't solve the thing. So that's why you check your answers, is when you're solving rational equations, often this will happen. So no solution on that one. Let's try another one. 6 over x plus 3 equal x minus 6 over x plus 3 equals 2x over x plus 3 all plus 2. Okay, we want to solve that for x. So clearly the denominator here is x plus 3. So we'll multiply both sides by x plus 3. So x plus 3 times the whole left side, x minus 6 over x plus 3 equals x plus 3 times the whole right side. 2x over x plus 3 plus 2. Okay, and we distribute this out. So we get x times x plus 3 minus, Now x plus 3 times 6 over x plus 3, the x plus 3's will cancel, so we'll just have 6, equals, then over here on the right side, distributing this on the first term, x plus 3's cancel, we just get 2x. And on the second term, we have plus 2 times x plus 3. Okay, and so from here, we start expanding, combining like terms, and then go from there. So expanding this x out, we get x squared plus 3x. Right away, I know this is at least a quadratic because I have an x squared term, which means I'm going to have to make it equal to 0 and factor to solve. But first, we've got to finish the right side. So plus 2x plus, distributing that 2, we have a 2x plus 6. Let's combine like terms over here. Okay, 2x plus 2x is 4x. So now I did do a shortcut step there, but that's okay. I'm going to subtract, I'm going to move everything to the left side because I have a positive x squared on that side. So subtracting 4x from both sides, 3x minus 4x is negative x. And subtracting this 6 from both sides, negative 6 minus 6 is negative 12. And hopefully this factors. X squared breaks into x next. Now 12, we want to get a negative 12, so one has to be positive, one has to be negative. So I'm going to try for 4 and 3 here, and I want them to add to a negative, so if we go with negative 4 and positive 3, that'll work. So then we set each factor equal to 0, and we get x equals 4, and x equals negative 3. And so now we go check. Let's go check, check. X equals 4. Does that solve the original equation? Let's see. We have 4 minus 6 over 4 plus 3. Does that equal 2 times 4 over 4 plus 3, all plus 2? Now this is not nearly as messy as that previous one, so let's just do this one algebraically. Okay, so we have 4 minus 6 over 7. Does that equal 8 over 7 plus 2? Well, let's see, we need to get everything over 7 apparently. So to get 4 over 7, multiply it times 7 over 7, so 28 over 7 minus 6 over 7. I'm going to go ahead and subtract those. And then we'll have 8 minus something, or plus something over 7. 2 can be written as 14 over 7, so we'll have plus 14 there. Now 28 minus 6 is 22. And 14 plus 8 is also 22, so that does work. X equals 4 is a solution. And now we just need to check x equals negative 3. So I'm going to box that off to the side so you can tell that that's separate. Now let's check x equals negative 3. So plugging into the original equation here, actually you can see right away, if I plug it in on the left side, we get negative 3 plus 6 over negative 3 plus 3 equals, stop right there, negative 3 plus 3 is 0. And we can't divide by 0, so that's not a solution. So x equals 4 is the only solution here. Alright, so that's basically it for solving rational equations. I want to do one more simple example in solving. Show you how to solve for a variable if there are no numbers involved. The process is the same. Students kind of get a little caught up on this sometimes, so I want to show you just in case to make sure you're clear on this. So say we want to solve this for a. We're not solving for x, we're solving for a. Okay? Same thing, a is in the denominator, and we have fractions. So let's get rid of the fractions. So the three denominators here are a, b, and x. So the lowest common multiple of those is their product, a times b times x, because they have no factors in common. So we'll multiply the whole left side by abx. So I have abx times 1 over a plus 1 over b equals abx times 1 over x. This should get rid of all the fractions. So distributing abx times 1 over a, the a's will cancel and we'll just have bx. And distributing abx times 1 over b, the b's cancel, so we'll just have ax. And then over here the x's cancel, so we just have ab. That did get rid of the fractions, so that is good. Next step is to solve for a. Okay, so I know you're in the habit of solving for x, but we want to solve for a. Okay, the trick is to get all the terms with a on one side, just like you do with x without even thinking about it. So let's subtract that ax from both sides and get all the a's on the right side and all the other terms on the other side. So the only other term we have is bx, so we'll leave it where it is. So bx equals ab minus ax. Now we want to solve for a. The problem here is we have two a's. We have an a here and we have an a here. So to get them together into one a so that we can solve for it, the trick is to factor it out, which technically is what you do every time you solve for x. You just don't think of it this way. But if we factor an a out of both terms on this right side, we're left with a times b minus x. And now I've only got a single a written in the equation, so I can solve for it. All I have to do is divide both sides by what a is times here, b minus x. And they cancel, so we get a is equal to bx over b minus x. And because this is not numerical, this is not going to really be possible to check, but it will work. If you plug that back in, it'll work. Okay, so there's how you solve for a variable. Get all the terms with that variable on one side, all the other terms without it on the other side, and then factor that variable out. That is it for section 7.5. Tune in next time for 7.2.